this is Echo 77 Sierra Romeo. Today we're gonna build the portable end-fed half-wave antenna for 40 to 10 meters, multi-band antenna. And these are the ingredients of my hopefully successful recipe for today. So what do we have here? Well, for the 49 to 1 transformer, unun transformer, we need a ferrite core, and this is supposed to be FT24043 mix ferrite ring or ferrite core, which we're going to use for the 49 to 1 transformer. This is the SO239 connector, the chassis connector. These are some nuts, bolts and washers. This is 100 picofarad 3 kilovolt capacitor, and this thing serves to flatten our SWR on the higher bands, that is 10 and 15 meters, or 10 or 17 meters rather, bands. So this comes at the end. We're going to have to solder this. Then we have some enamel wire. This is a 1 millimeter diameter enamel wire, which we're going to use to wrap this toroid with two primary and 12 secondary windings, overall 14 windings around this ferrite core. And at the end we have this beautiful housing for my portable end-fed half-wave antenna, which is printed by my buddy Daniel, Echo 75 Yankee Zulu. And as you can see, I don't know if you can see this, it has some, engravings. This is my call sign, Echo 77 Sierra Romeo, on both sides. We have a slot for SO239 connector, and at the middle we're gonna put our ferrite core or ring, and then we're gonna zip this ring with some zip ties so that it can be, steady and durable, I should say. So yeah, I think we have all the ingredients for our end-fed half-wave antenna, and we can start with the build. All right, so first things first, I just inserted my SO239 connector and tightened it with the some bolts and nuts at the end. So I intentionally left this one not tightened, because this is the one that I'm going to use as my ground, for my ground. So this comes at the end. Now let's go to the most complicated part, as they should say, and this is the winding of the 240-43 toroid ring. So what I did, I have prepared the around 1.2 meter length of enamel wire, and then I took around 8 inches of wire, bent it over, and then I used a simple system for twisting this wire. I took my the tool, I don't know how to say it in English, and tighten it on one end, and on the other end I just use this simple system to make turns, and then I twisted it. So this piece of wire, you're going to use it for your primary windings, your two primary windings, and don't forget to scrap off the paint, the isolation at the end here, because it's gonna get harder to scrap it off later once you wind your toroid with the wire. Why? Because you're going to need to solder this, and in order to solder, you need to take off the isolation. So yeah, let's go to the winding. So as I said, what you're going to do and what you need to do is, first of all, you're going to leave some space here, and then you're going to twist this wire from the inside of this ring twice. So remember, you are counting the number of windings by the wire that is passing through the ring, so inside of the ring, and this is how you're going to count it. So we need 2 primary windings, meaning that 2 times this twisted wire is going to pass through the center of this ring. And this is how our ring looks after the winding. So 2 primaries here, and then 12 more secondary, okay, secondary windings. So let's count those. 1, 2, 3, 4, 5, 6, 7. This one counts as 8, 9, 10, 11, 12, 13, 14. And then this piece of wire goes to your radiating wire. And this is grounding, and this goes to the center pin of SO239 connector. Now, what you have to do is, when you put it here inside the housing, so it's going to look something like this, okay? And, okay, this goes to your radiating wire here, let's say. Now, this goes to the center pin down there of 239 connector, and this is your grounding that goes here, okay? So what you need to do is basically remember that we scrapped off the isolation from this piece of wire. This is something that I'm going to solder here, okay, here to the center. So this goes into here. And this one is going to be soldered here on the grounding lug. Now, one other thing that we shouldn't forget is the capacitor. So capacitor goes, it should be soldered here, so it makes a short between the center pin and the grounding, okay? So it's going to be something like this, okay? So it's going to be soldered here. And this helps us flatten the SWR on higher bends. Okay, so let's go for it. All right, this is how the final product looks alike. This is 49:1 unun transformer, and I'm pretty satisfied with how this went. I mean, you can see, so, you know, there is SO239, there is a grounding lug, there is a capacitor that is installed, 100 picofarads, 3 kilovolts, there is a transformer itself, 49:1, 14 windings, 2 primary, 12 secondary, and there is a radiating wire lug on the back, okay? Everything is hardened through the zip ties, and the final thing that is left to do is to test this thing for continuity. So I have a multimeter here, okay? I'm going to put it in a buzzer mode, and let's try. Remember, we should get the continuity or the buzz sound everywhere because we have shortened ground and central pin. So let's check it first of all to see if we have the direct connection or continuity between the central pin of SO239 connector and radiating wire lug. You hear that? That looks good. And let's see now for the ground as well. Okay. So yeah, that's it. In the next video, I'm gonna take this thing out and test it. I'm gonna measure it when I put the wire. I'm gonna need for 40 to 10, I'm gonna need around 20 meters of radiating wire. I'm gonna take the thinner wire this time, because this is supposed to be a portable antenna. So the aim is to get the 40 meters resonance. I'm gonna try to tune it up for the CW portion of the 40 meters, and then we're gonna see how it acts on its harmonics. It's supposed to be resonant on 40, 20, 15 and 10. And maybe I should have the radiating wire in two pieces, 10 meters and 10 meters, and then I'm gonna probably connect it through some kind of, you know, how do you call it? These small things, electric things that have, you know, small nuts inside. So if I need, for example, you know, resonant antenna for 20 meters, I can do that with 10 meters of wire, no need for another 10 meters. And if I need a full scope from 40 to 10, then I'm gonna have the second element connected. That means another 10 meters. And I can have, you know, the true multi-band 40 to 10 meter end-fed half-wave antenna. So this was Echo 77 Sierra Romeo, and I wish you all the best, 73, and I'm gonna see you in the next video.